Hello. Today we're going to talk about the composition of a function, and here's a new idea. So before we talked about one function, could be quadratic, linear, or I could add two functions together, do some operations. Today I'm going to work on something new, is how to create a new function by composing two different functions. For example, let's talk about French fries. If I have the potatoes, and I have to do function for the potatoes to cut the potatoes first. So my function is cutting the potatoes. The domain is the potatoes, and the range is the cut potatoes. Now I need to fry the potatoes, so I need another function that takes the cut potatoes and fry them. So the second function is frying the potatoes. So altogether I can have a function that cut the potatoes first and then fry the potatoes. Therefore the output of the first function is an input. The first function, which is a cutting, is an input for fries, which is the cutting potatoes is an input for fries. Okay, let's talk about this here. So the output of one function is the input of another function. The notation f of g of x or f of g of x. And the idea of the potatoes here is that g of x is the cut potatoes, and f of g of x is frying the cut potatoes. So here f of g of x is cutting, is frying the cut potatoes. Alright, so let's get an example to understand that. So if I ask you and say that let f of x, let's get an example, maybe another marker. So let's f of x equal x squared minus 4x plus 1, and g of x equals x plus 2. So now I need to know what is f compound g of 3, and I write it this way. Okay, so this way, based on that rule, that is equal f of g of 3. F is the outer function, g is the inner function, and now I plug x equals 3. Okay, so I start from the inside first. So the inside comes first, there's the inside comes first, and then the outside. Cutting the potatoes and then fry the potatoes. Okay? So what is g of 3? What's cutting the potatoes? So g of 3 here, I plug 3 here, so I have 3 plus 2 is 5. So that would be f of g3, which is 5. And now I plug 5 here and get f of 5. So what is f of 5? 5 squared minus 4 times 5 plus 1. Minus 4 times 5 plus 1. So 25 minus 20 plus 1 is 6. So f of g of 3 is 6. Let's get another example. G of f, so I'm going to swap it here, of negative 4. So now g comes outer and f comes inside of negative 4. Okay? Now I have g. Now what is f of negative 4? So f of negative 4, I'm going to plug negative 4 here. So I have negative 4 squared minus 4 times negative 4 plus 1. I think that would be 16, and minus times minus is positive. 16 plus 1 So 16 plus 1 is 33. So I'm going to go here and say g of 33. You can compute it with me. Okay? So what is g33? I'm going to plug 33 in g. So the x would be 33 plus 2 is 35. So here is the answer. Okay. So now I'm going to move to another idea is how to compute the domain of a composed function. So in order to compute the domain, you have to figure out how to compute the domain of the inner function. So here I have to find the domain of g of x first, and then find the domain of the composed function. So let's see that. If I have f of x equal 3x minus 12 and g of x equal 1 over x plus 2. Okay, find the domain of f compound g of x. Okay, I start first. What is the domain of the inside? So this is f of g of x. So I'm finding the domain of g of x first. So the domain of g, here's g, is a rational function. So the rational function means that the denominator cannot be 0. So I've set x plus 2 is 0 and solve for x. So x plus 2 equals 0. We subtract 2 from both sides, so I have x is negative 2. And this is the unhappy value. So therefore the domain is from negative infinity to negative 2 union negative 2 to infinity. Okay? Now let's compose the function here. So I have f, I'm going to write this down here, of g of x equal f of, what is g of x? Here's g of x, 1 over x plus 2. Okay, the idea here to make this function easier, the composing the function easier for you. Look at the pattern for f. So f is 3 times x. I put the parentheses for x minus 12. So each x, you put a parenthesis for that. And then plug whatever for x here, 1 over x plus 2. Is that clear? Blank parentheses for each x, and then do the whole pattern, and then plug 1 over x plus 2 here. Okay, let's simplify that. I have 3 over x plus 2 minus 12. Okay? So here, x plus 2 cannot be 0 here, and this is the same thing as here. So therefore the domain of f compound g of x is the same thing here, negative infinity and negative 2 union negative infinity, negative 2 and infinity. Alright? Let's get another composition with the same functions. So I got f compound g and g compound f, but I can make f compound f as well. Notice what? Suppose that we have the potatoes and my f function is cutting the potatoes. The potatoes is not very small, but I need to cut it again. So I can do double cutting, which means here I use the function twice, or I compose the function with itself. Alright, so f compound f is f of x. So the inner f and outer f is the same. So what's the f of x? 3x minus 12. So again, I have to test the domain of the inner function. What is the domain of 3x minus 12? this is a polynomial, so the domain of any polynomial is all the real numbers. So I don't have any problem here. So f, the domain here is f from negative infinity to infinity. Okay, so f, I plug this one here, so I get the 3x minus 12. There you go. And now, as I told you before, do that pattern, 3 times parentheses minus 12. So this is 3 times parentheses, which is x, minus 12. But now I want to get the f of 3x minus 12. So I'm going to plug 3x minus 12. Now because it's f compound f. So this 3x minus 12 is that one. But here is again 3x minus 12. And now we clean this, so distribute 3. So I have 9x minus 3 times 12 is 36 minus 12 is 9x minus 48. And now again it is a polynomial, so the domain of f compound f of x is negative infinity, infinity. Okay? Sweet. I have a little different example. This example is a little complicated, but it has everything in one example. So let's do that. I have j of x equal 1 over 2x minus 6, and k of x equals the square root of x minus 7. So I want to get j compound k of x and its domain. So first of all, j compound k of x is j is out, times, or I'm sorry, compound k of x, j of k of x. Alright, so now I have to test the domain of this function first, the inner function. So what's the domain of k of x? So k, let's make it here, k, the domain of k, which is the square root of x minus 7. When I go with square root, the radicands must be 0 or greater than 0. So x minus 7 must be greater than or equal 0. So I got here x is greater than or equal 7 by adding 7 to both sides. So the domain would be from 7 to infinity. Okay? So this is the domain of k. Now, I'm going to do the composed function. So j of, what is k of x? The square root of x minus 7. Now, let's do the pattern of j. So j1, and for each x use a parenthesis 2. This is x minus 6. So look at this one, they are the same, but I made a blank parenthesis so I can put this input here. So I have here square root of x minus 7. Okay? Alright, so now this is j compound k of x. So what kind of function is that? This is a rational function. Therefore, the denominator cannot be 0. So now I set the denominator to 0 and solve for x. That has two steps. We're going to work them together. Okay, so I have 2 times the square root of x minus 7 minus 6 is 0. I'm trying to find the value of x that makes the denominator 0. Okay, first we add 6 to both sides. So I have 2 times the square root of x minus 7 equal, add 6 for both sides, so equals 6. Then divide by 2, so I have here square root of x minus 7 equals 3. Am I done? No. How can I get rid of the square root? Square both sides. Exactly. So I have this squared and that also squared. Alright. On the left side I have x minus 7 and 3 squared is 9. Now we add 7. So x is 9 plus 7 is 16. Okay, so the value 16 is the value that is not, x cannot be 16. Okay, so let's do this here. So before I have from 7 to infinity. So here is, let's make 7 further here. This is 7 to infinity. So this is my first domain, all of these, but now I have to exclude 16. So I make an open circle, and here is 16. So I have two interval from 7 to 16 and from 16 to infinity. So my domain is from 7, close set, to 16, open, union, 16 open, and infinity. I hope that this is helpful for you, and see you in the next section. Thank you.